Hey everybody, Lars here. I'm exhausted right now, and I'm boiling hot. Um, you're getting this video on Sunday night, but I'm shooting it at 6:20 on Saturday night, and all day today I was at High Point Solution Stadium watching Rutgers beat Howard, but it didn't start out all that great. First of all, it was boiling out. Just too hot for a young Norwegian lad like me. And and as you know, I'm in the boot, so I'm limping around like Quasimodo. And we get to the stadium, and Howard jumps out to a 14-0 lead. Now, Howard isn't really that great a team, so Rutgers was supposed to really beat up on them. One of the very few games where we were definitely supposed to get a win. And Howard jumps out to a 14-0 lead. And then we don't exactly look like world beaters, but we do manage to claw together a couple of touchdowns. And we go into halftime tied at 14. It was very weird. But Rutgers came out swinging in the second half and ended up scoring a whole bunch of points. And we actually left the game when it was 35-14, and they won like 50-14 or something like that. They won by a big margin. But it was hot out, and I'm sure I got sunburned. I don't know if you can see if I look red with this Camtasia and sitting here in the dark in my living room. But man, oh Manischewitz, it was a bizarre day and a bizarre game, and I'm boiling and I'm exhausted because as you know, I shot your first video last night and I did some other stuff, and then all of a sudden I turn on Amazon Prime and I see that X-Men Apocalypse is available. And I didn't see it in the movies, and I could not stop myself. So I end up ordering the movie, watching the movie. I don't get to sleep till 2 o'clock in the morning. And then I got to be up at 7:30 to get ready for the game. Me and my friends left at the tailgate, blah, blah, blah. Just an absolute train wreck. But you need videos. So I am doing the second video for your Unit 1 review right now, and I will give it to you tomorrow, and then hopefully in the next few days I'll do that extra programming video where we just whip up a program real quick and you can see how I do that. But tonight we are going to look at Booleans, and we are going to look at if-then, and I actually whipped up a small little piece of code for you already. Just at the top of the program I list the relational operators, and we're going to use these when we compare values to determine whether a variable should be true or false, because that is what a Boolean variable is. It's very simple. It just holds one of two variables. I'll say variable 1. Make sure it is capital. When you type the word true, you'll see that it is orange. That is because it is a Python keyword, and you should not use it for variable names or later as we move on for function names. The same is true with false. So now variable 1 holds the value true, and if we print it, let's just print it real quick just to show you. Save F5. You can see it just prints true to the screen. Okay, so Boolean variables, incredibly simple. All they hold is either true or false. Now you might be saying, well, what good does that do me? Well, it's kind of a two-step process. I'm going to show you right now. Let's say we have two variables, num1 equal to 15, and let's say I have a second variable, num2, and I make that guy equal to 30, okay? Now, I can use those relational operators that we see up there to have Python compare the numbers and see what their relation is and put the result into a variable. So I'm going to say var3 equals num1 greater than num2, okay? Then I'm going to print. I don't want to print var. var3, okay? So let's look at it. Num1 is been assigned the value. Remember, it's not equals, it's assigned, and we're going to see that today because we're actually using the real equals for equivalency. The value 15 is assigned to the variable num1, and then below it, the value 30 is assigned to the variable num2. Remember, we always evaluate expressions from right to left in most programming languages and definitely in Python. So we get to that third line, var3 equals, see, I can't help but say it, var3 is assigned the value of num1 greater than num2. Now, num1 is 15, num2 is 30. Is num1 greater than num2? No, it's not. So the Boolean variable var3 is going to hold the value false. And when I print it, it should say false. At least I hope it does. Look, I got a true up there. I was from when I printed it before. And as you can see, it is false. Now, if we do something as simple as just change the sign, make it less than, well, now, all of a sudden it's true. Okay? Now, we can also say, is it equal? Now, we know certainly that it's not equal. But if I don't use a variable, and we can use hard-coded numbers and variables, let's see if num1 is equal to 15, well, then that's, of course, true. Okay, so you can see that over there. Let me get these things tighter so I can zoom in later. Okay? So that is what we do to create a Boolean variable on num2. I could also say greater than equal to. I could also say less than equal to. I'm just going to, for now, stick with greater than, and my value is going to be false. Now, the next thing you're probably saying to yourself is, yeah, okay, I can create Boolean variables, and I can use these relational operators in order to create these Boolean variables by comparing two numbers. But what good does it do me? You know, I have a bunch of variables. They say true, they say false. You know, who really cares? Well, this is why you're going to care, and I'm going to actually jump right to it. We are going to use these Boolean variables in order to make decisions. And the way we make decisions is with decision structures at the beginning when we start programming is with something called an if-then structure. But Python, you don't need the word then. We're just going to use if, and we're going to assume the then. So I'm going to type if, and then you don't have to, but I usually put conditions in parentheses. In some languages, you have to put the conditions in parentheses. Python doesn't care. Okay? Actually, I'll leave it blank this time just so you can see. And I'm going to say if num1 greater than num2, and then colon, and then I'm going to hit enter. And what idle is doing for me is doing my indenting. I want to then, if that condition is true, I will run the block of code that's indented 4 spots underneath that if statement. I'm not going to do a block of code. I'm just going to do one. And I'm going to say, in order for that to be true, it has to be less than. Okay? So, let's just run this. See what we get. All right, it does nothing. And the reason it does nothing is because var3 equals false. I'm not using var3, though. I'm actually doing it raw, right in the middle of the condition. If num1 greater than num2, is it? No, so it's false. So we don't run that code because the value is false. Okay, now, if I do what I did before, and we switch the sign, if num1 is less than num2, well, then it prints less than. Okay? Because I didn't print the Boolean value. I made a decision based on it, and then I ran the code underneath it. Okay? So this time the less than was printed. Now, what if I want to say, is it less than num2? Then print less than. But what if I want to do something else? It's funny I said that. If the opposite is true, I can use the else. And then I can print greater than. I run it, and of course it's still less than. And you'll notice that this was ignored, because if this is true, then the else isn't, and the else gets skipped. But if I go back here and I switch things up so that if is false, well, now it says greater than. Okay? Because this was false, so it skipped the main one, or the then, which is implicit. You just understand it. And it goes and it prints the else. Okay? Now, this has an interesting little problem. Maybe I'll show you now. Yeah, I will show you now. First thing I'm going to show you is this. You see how I do num1, num2 right there? I don't have to. I can just put the Boolean variable in there and say var3. So right now, that is false, so I should get greater than. And I do. Okay? But if when I create that Boolean variable, I switch it and I make it true, then I get my less than. Okay? Remember, if I'm going too fast, because I'm trying to get this one done in like 20, 25 minutes, slow down. It's YouTube. Stop. Look at the code. Now, as usual, you don't have to type this code in. I'm going to take Rev2 and I'm going to put it up in Sakai for you. But just so you know, if you want to see something, play it over and over and over again. That's one of the good things about having these things on YouTube. You watch it as many times as you want. All right. One other thing that I was going to show you. Do I want to leave var 3 in there? No, I don't want to do it with var 3. I want to do this. I want you to show you something that could bite you later. I'm going to use parentheses to assuage my OCD, and I'm going to say if num1 is greater than 10, print, well, no, I'm going to say less than 10, because that way I don't have to change my prints. If num1 is less than 10, print less than, else print greater than. So num1 is 15. So it's not true. It should say greater than. Let's find out if our logic is correct. It is. It says greater than, okay? So now if I come up here and I change num1, and I make it an 8, I rerun it, it says less than, okay? But we have a problem. And I bet you some of you have already figured out what that problem is. What if num1 is 10? Okay? Is num1 less than 10? No, it's not. So it's going to be false. And skip this and print this. So I'm going to print greater than. Let's confirm that by running the program. So it says greater than. But is that true? No, it's not. Because it is 10. They're equivalent. It's not greater than 10. It is 10. So we have a situation here where we've created an if-else structure, but we really don't have a binary decision. We have 3 different possibilities. And I want you to see this right out of the box so you're aware when you compare numbers and you have situations like this, if-else is great. It's used all the time, but you've got to make sure it's a binary choice you're making and that there aren't more choices that can be had. If there are more choices, we have something we can do. We can use what's called an elif. And what I'm going to do in this case is I'm going to say if num is less than 10, print less than. Great. But then I'm going to use elif and create a new condition. I'm going to say elif num1 is greater than 10, print greater than. And then at the very end, I'm going to use else. And I'm going to say print equal. Now, as you can see, I'm using the else with no condition in there because I don't have to. Look at my logic. Is the number less than 10? Well, then this would be triggered and the rest of the block would be skipped. Okay? If it's not, we drop to the elif. Num1 greater than 10? Yes. Then I print. If not, well, then I ignore this and I drop to the else. Okay? If I get here in this structure, it has to be 10. Okay? Because this would have triggered if it was less than, and this would have triggered if it was greater than. So the only way I'm ever getting to that else is if I actually have 10 as my number, which I do up here. So I'm kind of using logic in order to not have to do another elif and check the condition num1, equivalent to 10. I don't need to bother. It's literally the only thing that's possible if I get to that spot. So let's take a look and see if the code works. I'm hoping it does. Greater than, and it is, because 12 is greater than 10. So now I'm going to do 8. And it is less than. Uh-oh, we're in good shape. We've got one more thing to test, though. Now, if I say 10 for num1, both of these conditions, less than and greater than, are not going to trigger. And I'm going to drop down to the else, and I'm going to print equal. If the programming gods are with me, that's exactly what's going to happen, okay? So I want you to be aware when you're using if-else, make sure you got a binary choice. If you don't, you create an elif structure like this, and you start checking things along down the line until you decide for yourself that you have, logically the only thing that's left, then you can use the else again. Okay? There is one more thing I want to show you, but you know what? At this point, I want to save this code because I want you to have it, and I want you to have it to look at. So I'm going to block this off. 1, 2, 3. And I'm going to create 2 new variables. I'm going to say num3 is 10, and I'm going to say num4 is 40. And then I'm going to show you one last thing. Let's say I say if num4 greater than 30, print greater than 30. Good enough. Okay, so now when I run this code, it should print GT30, greater than 30. So we're in great shape. But what if I wanted to see if it was greater than 30 and less than 60? Okay? Now, I could do 2 different things. I could, nest a bunch of elifs and check after I got through this. I could then come under here if I wanted to. I could then come under here and say if num4 less than 60. Is that what I want to do? Less than 60. So num4 less than 60. Yes. I could change. I can make this greater than 30. And then when I know that's greater than 30, then I can check to see if it's less than 60. And if it is, I'll print 60. Right? I think that's going to work. All right? Because that's where 40 resides. But what if I want to do it all on one line? What if I want to be more elegant about it? What if I want to be more concise? The way I do it is this. I can use Boolean algebra operators, as you saw in your slides, to chain these conditions together. Now, if I do this, if num4 is less than 60, then I print GT60 and less than 60. I mean GT30 and less than 60. So now I come to this statement, and is num4 greater than 30? Yes, it is. That's true. But then I have to come over here and evaluate this. Is num4 less than 60? In this case, it is. So I have true and true. And if you do truth tables, or if you ever had logic design, or you know about the Boolean operators, with an and, both have to be true for the entire statement to be true. Okay? In this case, it is. So I'm going to print GT LT60. Let's run it and find out. Yeah, I got it. Okay? Now, let's have something else going on. Just in case things don't work, we don't just get a blank screen. I'll just say nope. All right, so now if I take num4 and I put it out of that range and I run it, nope, because it's not between those two things. Now, I can also say OR. Now, what OR does is if either one of these is true, it'll print that statement right there. So, if num1 is greater than 30, you're great. Num4 less than 60, you're great. So, what do we have there? If you guys have ever taken symbolic logic, you'll see we have tautology there. That's always going to be true. So we need to find something a little more interesting. If num4 is greater than 30 or num4 equals 7, we will print the line. And I'll just get rid of that. Okay? So, let's run it with a 10 and see what we get. We get GT30. Whoa, should we have got... Oh, yes. Because num4... Didn't I change it? Oh, I changed num3. Dun, 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 dun. 10. Always something got to go wrong. So now I get a nope, right? Okay. Let's see one that's greater than 30. All right, we got greater than 30. Now we test our other one. I'm going to say that it's 7. So when I evaluate this statement, num4 greater than 30, no, it's not. But it's going to see if it's equal to 7. It is, so I should get GT30. And I do. Okay? So remember the OR. Now there's a third Boolean operator, which is not. Okay? Not is kind of a descriptor. It would go in front of something. So I would say num greater than 30 or not num equal to 7. In this case, you know what? I'll be a tricky guy. And I'll change it up there so my 7 is still going to work. Okay? So now if num4 is let's say 70, I get a GT. Why did I get the GT30? Oh, because it's num4 is not equal to 7. So yeah, that's, you know what? It's another tautology. That's always going to work that way. Because num4 equal to 7, num4 not equal to 7 is true. And then that was a false, but it didn't matter because it got triggered because that was greater than 30. Gotcha. Now I'm going to try 20. 20 said nope. Okay? But now if I say 7, and this is the one I want you to see, it's going to say GT30. And you're going to say, why? Because now you have not equal to, but I reverse it by using the not. So num4 not equal to 7, well, that's not true. That's false. It is equal to 7. But by taking that not, boop, I flip the Boolean, which is binary, from false to true. So now I'm triggering that true because I didn't trigger this one. Num4 is not greater than 30. It's 7. But when I do this, it comes up false, and I reverse it. Okay? I don't want to say tricky, little nuanced. Most times when we do things in code, it's not going to be confusing. It's going to be easy to see and easy to do. So I'm going to go back and leave the and by itself. And I'll make that equals to 7. And you guys can play around with it when you get this code. Okay? So that's it. Hold on, I'll do a grand tour and run everything. I hope it works. Dun, 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 dun. And there you go. Equal nope. So I'm going to save this code. I'm going to put it up on Sakai for you guys. You bring it into Python and you play around with it, okay? You print these variables out. You can change these variables. Truth be told, you want to play around with the input statement so that you can enter the variables. Doing things like this is going to come into play in your second assignment. You haven't gotten it yet because you're not going to get it till Monday, but when you get the second assignment, you're going to go, aha, and this is the video that you want to watch when you want to tool around with the things that are going on in assignment number 2, okay? Other than that, I'm not going to sit here and clobber you with a million announcements again. You just had it 2 days ago when I did video 1. Pretty much the same thing. Getting you your resources. You have the slides. You have the Zell readings. You have video 1. Now you're going to have video 2. I'm going to get you the assignments on Monday, so you're going to have them to work on for a full 8 days, okay? Along the lines, maybe Tuesday, Wednesday, I'm going to give you that third video. I'm going to do the third video, and I'm probably going to sit down just one night, click it on, and real impromptu just bang out the change program so you can see that work. Because I want you to, I don't know, I want you to hear me like do in education, we call it a think aloud. And when I work through the process in my head of doing that program, I'm going to talk as I do it, and I'm going to tell you what I'm thinking. And I'm just going to start from nothing. And we're going to whip up a program that will take an amount of pennies and tell you how many quarters, how many dimes, how many nickels, and stuff like that. All right? All right, then I'm going to let you go. Hopefully you are enjoying the end of your weekend. I have Seattle in both my suicide pools. So if you're watching football later, root for Seattle. I need them or I'm out. One of them is a decent amount of money, too, so I don't want to lose. And I was lazy, so I just took Seattle because they were the biggest point spread. They're favored by 10. I think they're playing Miami. Miami had to go cross-country to play in Seattle, and Miami's not that good. Seattle's supposed to be really good. So I figured that was an easy one. But now, if you know how suicide pools work, I can't pick Seattle for the rest of the year. With suicide pool, you just have to pick one winner, and then you go to the next week. And they have to win against the No, some you have to win against the spread. In this one, you don't. You just have to win the game. But it's not easy to pick a winner every single week. So you get a whole bunch of people together and you see who can do it. And the guy who does it the longest keeps all the money. All right, don't tell anyone. Gambling is illegal. And I do not promote the practice. But that said, root for Seattle. All right? All right, then I'm out of here. Look for another video in the next couple days. I'll probably do an announcement tomorrow. I'm going to get you the Unit 1 assignments on Monday. And life is going to be good and full of Python. All right? I'll talk to you later. Bye-bye.